happens through the generation of free radicals by the action of electrons, ions, excited neutrons, and photons present in the discharge. This process also creates roughness, breaking the crystallinity, similar like process shown before. The radicals react with atmospheric oxygen, creating the functionalization of polymer surface. Again, new groups, carbonyl, hydroxyl, and carboxyl groups, able to react with another kind of paint applied on the plastic surface. In this picture, it's possible to see the basic mechanism of the corona treatment working. In this picture we see the electrical discharge on the top of the upper layer. The electrical discharge breaks the chemical bond between carbons here, producing a reaction with the free bonds with the oxygen, creating the chemical groups we already discussed, carbonyl, carboxyl, etc. Here are some process parameters. Okay, frequency range usually applied 10 to 15 kilohertz, output power 50 kilohertz, voltage 0.5 to 25 kilovolts. Okay. The effectiveness of the corona treatment depends on the specific material being used. So different plastics, films, materials have different characteristics and that different amounts of sleep in additives, which will determine the effect of the corona treatment. So there are no limits with regard to the materials that can be corona treated. However, the required intensity of the treatment corona may vary significantly. Here are some tips we can mention about the corona treatment. Lower frequency helps to decrease contact angles, and increase the voltage causes an increase in oxidation. And here a very useful formula in order to preview the activation energy necessary to increase the surface free energy. Okay, it's related with the length of discharge electrode, speed of substrate, and the power of the corona discharges. After corona treatment, there are another variation of this treatment, that's the plasma. Plasma is made under electric field too, but in this situation, you have a controlled gas atmosphere with usually noble gases and without the regular air or at the vacuum. The electrical fields are 25 to 100 watts at very short time, 15 to 90 seconds. You have similar radicals in roughness formation as corona treatment, and the surface energy increases and decreases the contact angle theta, a similar method shown before. Here an example of some plastic pieces inside a plasma chamber, and at the right side the basic mechanism. You have the electrical discharge. This electrical discharge delocates some particles from the energetic levels from the gas, and this atomic particles hits the surface of plastic, creating the roughness and the chemical groups. Here an illustration of the activation of the polymer surface using argon on the polystyrene. So the argon particles hits the polymer surface, breaking the chemical bond and removing the hydrogen from the molecule of the polymer. And here, an example of creation of hydroxyl groups on PP surface in an oxygen plasma. So, let's suppose that I have here the plastic without the hydrogen. The hydrogen was delocated by the heat with some noble gas. You have the oxygen inside the chamber. This oxygen molecule react one oxygen with the carbon, create a single bond with the free carbon, and another oxygen group here with electron pair available to react. Again, during the process, another hydrogen is removed from another carbon, and this hydrogen, this free hydrogen, reacts with the electron pairs of the three electron pairs of oxygen, creating hydroxyl groups. And the reaction is happening so on. This way, after the formation of the hydroxyl groups on the polymer surface, the hydroxyl groups, for example, can react with the isocyanate group in the coating or an adhesive applied on the plastic surface, creating a very strong covalent bond with very good adhesion performance. Here, the influence of how different gases can produce different levels of roughness, changing the topography of the plastic surface in different ways. Okay, so we have 4 example gases here: argon, oxygen, nitrogen, and carbon dioxide, showing how these gases and the atomic particles delocated from the level of these gases can heat in different forms, different ways, the plastic surface, creating different levels of roughness. And now, how these different gases can change values in contact angle and the surface free energy. In the left graphic, it's possible to see that the nitrogen looks like the gas that is able to produces the lower contact angle and the plasma treatment conditions of this situation. And the right side, a table with the increasing of surface energy after some gases. In the first line, the low density polystyrene without any treatment with 31.9 of surface tension. In the following, the gases. In this situation, argon looks like a good option to create a higher surface energy, able to create a good condition to adhesion process. And now, the most common way to create a good adhesion on plastics, the CPO. CPO, or chlorinate polyolefin, is a very interesting molecule because you have the chlorine. The chlorine has a unique combination of large electron affinity and minimal atomic radius, yielding near maximum London forces. In other words, chlorine is very electronegative, so it's able to be attracted by any kind of polar groups on the plastic surface. Besides this, chlorine has a very small atomic radius, so it's able to create a very good proximity. So it's able to stay as closer as possible of the plastic and the coating. The organic part of the molecule is able to be compatible with some organic binders used in the coating, and the chlorine is attracted by the plastic by the polar groups on the plastic surface. Even they are in small quantity. Here a cross section of OEM plastic part applied with adhesion promoter. So we can see here that CPO stays between substrate and the base coat like a kind of primer, okay? Linking the two surfaces, the base coat and the substrate. You can apply the CPO as adhesion promoter, spraying in solution, or